Welcome to my second part of the introductory part to chemistry. Hopefully the first video had made sense. So now let's continue. So when it comes to significant figures, you need to understand that there are rules which are applied. So what are those rules which you need to know when it comes to significant figures and calculations? Because when you're finding numbers, when it comes to chemistry, you'll be encountered with different numbers. Now, in one main significant figures, are you supposed to put that? Because, for instance, in the question, if it has two significant figures, so meaning that your answer has to be what? Two significant figures. But when you're answering questions, when you're doing your solvings, add all the numbers so that you have an accurate answer. That is my advice. So let's now jump into looking at the things which you need to consider. Please, if you haven't subscribed, subscribe so that each time I post a new video, you're notified, you're not left out. So the first one, it is what? Non-zeros. Always counted as what? Significant. What are non-zeros? So any number other than 0 is significant. Then what about it comes to zeros now? For instance, look at this number. So long as you have a number and a decimal point, then zeros, these are zeros, are not what? Significant. So that's what you need to know. Then the other one, if you have a number, a non-zero, then a decimal point, then zeros. These zeros are what? Significant. Wonder this one has how many significant? 4. Then when it comes to a number which doesn't have a decimal point, like 100, these zeros are not significant. Or 1000, so long as there isn't a decimal point, these zeros are not what? Significant. But it changes each time when you have a decimal point, a number and a decimal point, then zeros follow. Then these are how many what? 3 significant figures. Then the other one, same like this one. So long as there's a decimal point, then there are zeros also and a number. A number here, like I had explained, is more like this one, which I had explained 100, 200. So long as it's a number, they are significant. It is 3. So that's what you need to know about the significant figures. So now you need to round off. Also rounding off things you've been encountering once. Put them whether in standard form or whatever form you find your answer, you need to round them off. So the rule is just about less than 5. If the number next to the number which you want to round it off, maybe for instance this one, you're rounding it off to 2 significant figures. So we're interested in that 3. So the number this side, it is less than 5, so meaning that it's just the same as 3.0 or 3.30. So one and the same, because this 0 is not what? Significant. Not so. Then if the number is greater than 0, like for this one, it is what? 1.4. That's what you need to know. So now let us see some examples. Like for instance, you divide this on your calculator, just punch that, just put this in your brackets for accuracy's sake. Also that one, divide, then it will come out, then you do that. Same with this one, just put them in brackets, also that, so that you have a better answer. Then you try out those. Same with this one, you have been given the formula and what each letter represent. Here we're just interested in the significant figures and also counting that. So you find your R, so that you see how many significant figures it has. So those are the answers. You can check them for the first one, for in 3 significant figures. Also that one, same with this one, you can check it out. Just put that, punch out on your calculator, it will come out. Same like this one also, you can check them out. So just the same things which I was explaining at first. This is what has happened, what is happening here. So now when it comes to dimension analysis, I won't explain much. I also did this in other videos, so I'll just give you a hint. So like for instance here, 7 inches, all you just need to do here, we're interested in letters, units, sorry. We're interested in units when it comes to dimension analysis. We're not interested in numbers. So do the reciprocal of this when you're converting it. So 1 always, then inch over what are you converting this to centimeters. So how many inches in 1 inch, how many centimeters do you have? It is 2.54 centimeters. Then you do that, then the inches will cancel out, then you just multiply this, then you have that. So whatever, let it be kg, anything, centimeter cubed, just know that the converting factors, that's what you need to know. Then when it comes to temperature, it is important that temperature is always used in what? Is expressed in terms of Kelvin. I'll tell you the reason that, because most of the time you might be given temperature in Kelvin, in degrees Celsius, you need to convert that into Kelvin. So like for instance, look at this. This is a formula, you need to know it. Just add your degrees Celsius plus this value. For instance, if you have 20, just do that, then you have that. So for instance, now what about if temperature is 0 degrees? What does it mean? Does it mean that something, that temperature, does it tell you? And this is the reason why we use Kelvin instead of 4 degrees. Because when you see 0 degrees Celsius, you feel that you might think as if there isn't any energy that thing has. But when you look at in Kelvin Celsius, when you add 0 degrees with this value, you have the same value. So no wonder we use temperature in kelvins instead of degrees Celsius, because 0 degrees, it means like there isn't any temperature. But when it comes to kelvins, it tells you that it does what? Temperature, not so. It tells you, no wonder temperature in kelvins tells you the kinetic energy, what that substance is, does what? Has. So that's what you need to know about temperature in what? In kelvins. Then when you want to find your temperature in Fahrenheit, this is the formula which you need to use. Like for instance, 20 degrees, you just replace here. Just replace, then you work out like I did here. So you find that here the degrees will cancel out, then you work out, just punch out in the calculator, then you have that. So when, for instance, you're given that, then you take it back into what? Celsius, just replace here, then leave it out here, then work out, it will come out. That's what you need to know, as easy as that. Then when it comes to matter, what you need to understand is that they are mixtures and also pure substances. This will make sense as we now start looking at what? Elements and compounds. What are they? And atoms. So that's what you need to know about chemistry when you're studying chemistry. Please like, subscribe, share to other people, and also click the notification button so that each time I post a new video, you are alerted. Thank you. If you have any question, please, you can reach me out.